Good morning. Okay, so in this video, you're probably going to hear me drinking water a lot because my voice is weird and it's been weird for a while. Anyways, this video is for the purple group. Yay, purple group. So starting on Amplify, you're going to go to Force and Motion. You're going to go to Lesson or Chapter 2. You're going to go to Lesson 2.5. And you're going to go to Activity 2. Okay, I'm going to try to make this video pretty quick, show you answers pretty quick, but I also want to be thorough about going through the concepts. So click on the simulation. Hopefully my computer is kind. If it's not kind, then I don't know what we'll do. We'll just have to keep going with the video and Amplify loads. Okay, so I have a copy of the document right here that I will be filling out. So the first step on this document is select 2.5 Purple Explorer from the Force and Motion Sim menu. So I'm going to go to the menu. It's up here in the three little lines. I'm going to go to 2.5 Purple Explorer. This is what your screen should look like. If it doesn't, you clicked on the wrong thing. So then, according to the instructions, I'm going to tap an object and record its initial velocity. So tap on it. It's 5 centimeters per second. So I'm going to type that and put 5. Okay, and direction is definitely going towards the right. So we would type right. Okay, and I'm going to read press run and then press prepare force. Set up the test and test the force that will cause each desired velocity change, A through D, listed in the data table below. Each velocity change can use only one force. Use the force panel to set up the force direction and force strength. Press exert force, observe the object's motion. Did you cause the desired change? Hint, press analyze. For data about velocity, use the Grumbler video view data. That's, I think, the blue button. I'll show you that. If yes, record the force direction and the force strength and go on to the next desired change. If no, press reset and try again with a different direction and or strength. Okay, so this is my desired change or changes in the data table. I hate this thing down here. Okay, so the first one is speed up 7 centimeters 2 centimeters per second to the right. Okay, so if this guy is going initially 5 centimeters per second to the right, and I want to speed him up, I have to prepare force, and I have to do it in the same direction, right? Because I want him to speed up, and he's already going right. So I know that I have to apply a force towards the right. That's a given. So I can put that in my table because I know right off the bat, if I want to speed an object up, it's got to be in the same direction it's going. And this is going right. Okay. Same thing with this. I want to speed it up and it's going right. So I know that the force direction is going to be right. So I haven't even done the simulation yet. I can tell before even doing the simulation that I'm going to have to add a force to the right. To slow an object down, if it's already initially going right, I have to add a force in the opposite direction. Remember, when we're trying to slow an object down, we have to add a force in the opposite direction. So I know that the force has to be applied to the left. Okay? Reverse direction's the same thing. If it's already initially going to the right, which it is, right? It's initially going to the right. Then I know if I want to reverse the direction, I'm going to have to apply a force to the left. Oop. Okay, so I have all my force directions. Now it's going to be the force strength. I'm going to take them step by step. So the first one, I want to speed it up 7 centimeters per second. If it's initially going 5 centimeters per second, and I know I have to add a force to the right, then I'm probably going to need 2 more clicks to get this guy faster. So I'm going to test that, following those instructions. So I'm going to go to run, like the instructions told me. I'm going to prepare a force, like the instructions told me. I'm going to add a force in the right direction, 2 clicks. I'm going to exert a force. Okay, it's sped up. Let's see, clicking analyze, let's see if it's sped up to 7 centimeters per second, which it did. This is our end velocity, and this is the change. Okay, so end velocity was 7 centimeters per second, so I know that I achieved my goal. So now I need to look at force strength. In order to do that, that's what this direction is telling us to do. We're going to click this blue button down here. We're going to rewind back the video till we see the arrow, and we see the force strength is 20. So I would put that right here. And that makes sense, right? We gave it 2 clicks. It was 5 centimeters per second. Then it went up to 7. So if you know that for the 7 centimeters, you know that you're going to need 5 clicks for the 10. So let's do that one. Go to build. It resets it. Go to run. Okay. Reset the simulation. Prepare force. We know that we are preparing it to the right, and we're testing 5 clicks. 1, 2, 3, 4, 5. Okay, click, exert a force. Whoa, that went really fast. We sped it up. Go to analyze. Our end result was 10 centimeters per second, which is what we wanted. And we did it towards the right, good. So now we need force strength. Rewind it back. And we see that it is 50. Yay! Okay, so this would be 50. Okay. Here's where it gets interesting. So we want to slow it down to 0 centimeters per second. And we want it to stop. Okay? We have to add a force in the opposite direction, which is left. We know that. Let me reset this. So we're doing C right now. Okay, if this is initially going 5 centimeters per second, I need to add a force strength in the opposite direction that is equivalent to this initial velocity. Okay, so I know that I'm going to add a force in the left direction, but it needs to be the equivalent to this initial velocity. So I'm going to say it's going to be 5 clicks because this is 5 centimeters per second already. So let's click run. Let's prepare force. 5 clicks. 1, 2, 3, 4, 5. And remember, we're going towards the left because when you want to stop or slow down an object, you have to apply a force in the opposite direction that it's going. And it stopped. So let's go to analyze. And our end result was 0. So we know that we achieved our goal. Remember, it was supposed to be 0. And we did it towards the left, the opposite direction to make it stop. So let's go force strength. Wind back the video. Ooh. So it is 50. So we know that it's 50. Okay, this is reverse direction. Okay, so we know we have to go towards the left. So if we reset this, we're going towards the left. Our initial velocity was 5 centimeters per second. So that means that we need to have more than that towards the left. Okay, if we have it 5, that stops it. And we know that we want our end result to be 2 centimeters per second to the left. So that means 2 more clicks than we had from stopping it. So go to run, prepare force. So instead of 5, this time it's going to be 7 because we need it to go 2 centimeters per second to the left. So 1, 2, 3, 4, 5, 6, 7. Exert force. Yay! It's going that way. Okay, so I'm going to click Analyze when it gets off the screen, just to check myself, make sure that it was 2 centimeters per second as my end result towards the left. All that negative sign means is it's going towards the left. So there we go. So I know that I did this part correctly. Okay, rewind back my video to get the force strength. And it is in fact 70. So I put 70. Okay, these are the correct answers for the table. So hopefully you have these. If you don't, then fix it. After you complete part 1, go on to part 2. So part 2, predict. If you exert the same strength force on 2 objects, okay, one with greater mass and one with less mass, which object reaches the target first? This is exactly like the ping pong ball and the golf ball exercise that we did. So remember, objects that are lighter have a greater change in velocity. It's that key concept that I showed on the class slides that says that more massive objects require a greater force. So that means that less massive objects have a greater change in velocity. So if you remember that exercise with the ping pong ball and the golf ball, the ping pong ball definitely reached the target before the golf ball did. So the correct answer should be the object with less mass has a greater change in velocity. So I'm going to highlight that. Okay. What should you do to make sure both objects reach the target in the same time? So you would definitely exert a stronger force on the more massive object. Definitely. Okay, to get them to go the same exact velocity and reach it at the same time. Okay, so let's test that. Part 2, test. Complete 3 missions. 2.5 purple mission 1, 2.5 purple mission 2, and so on. Okay, so these are just the missions. Select a mission and read the prompt. Press run and then press prepare force. Set up the forces and test your results. Use the force panel to set the force direction and the force strength for each object. A and B, exert a force. Observe the objects. Did they reach the target at the same time? Hit, press, analyze. Okay, so it's similar to what we've been doing. Okay, so let's go into the menu. Force of motion. Go to build. Make sure you're going to the menu. Let's start mission 1. So I'm doing mission 1, which is this column right here. Okay. So force direction. I'm going to want to apply a force in what direction? Prepare and exert a force any side in each to make them reach the targets at the same time. Okay, so obviously the targets are over here on the right. So I already know that the direction is going to be right for both of these. Right, right. Okay, right. All right, so I have the first part, definitely going to be right for both of these. Okay, for object A and object B. Okay, so I see that object A is definitely lighter than object B. So let's see, run. If I prepare force, let's just say hypothetically, oh my gosh, reset. Prepare force. Hypothetically, I'm just going to put one click on both of these and see what happens. I don't know what's going to happen. Just testing this. Okay, this guy is definitely more massive than this guy. So since I know that, I think this is going to need twice as many clicks because it's twice as heavy. So if you look at the mass down here, it's 1 kilogram for object A, but 2 kilograms for object B, which means it needs twice as much clicks as this one, or strength force as this one. So for B, I'm going to say 2 and just test it. I don't know if this is going to work, but let's see if it does. Wow, it's going really slow. Okay, I'm only doing initially 2 clicks, but I think it would probably work if you had more forces put on it, as long as you have twice as many for object B because it's twice as heavy. Yay! Okay, so going back to my answers, the force strength can vary on these depending on how many clicks you did. But let me rewind this back. You're going to notice a pattern. You're going to notice a pattern that it's always twice as much. So see how this is 20 and this is 10? It's always going to be twice as much as whatever object A is. So even if you did like 3 clicks here, you would have to put 6 clicks here because it would be twice as much. So let's write that. So it would be 1/2 the strength of object B, right? Because it has to be less than that. But this one would be twice the strength of object A. Okay, does that make sense? All right, a similar thing for the next couple ones. So if we go to this one, go to Build, and go back to the menu, and we go to Mission 2, the direction is going to change though. So for this one, it's going to be left, left. Let's see for Mission 3. It's going to be left as well. Okay, I'm not going to do all of these. I'm going to show you the answers, but that is the same sentiment. Whenever it's a lighter object, it's going to take half as much or a fourth of much or an eighth of much of whatever object B is. So let me show you the answers to that. So here are the answers to those ones. Oh, I didn't write it out correctly, but here are the answers to those. So hopefully you got something to this effect, that it's half the force on object B, 2 times for the heavier object, 4 times the force, 1/4 the amount of force for this object. Let's see for Mission 2. So this is Mission 2. So the heavier object would be A in that case for Mission 2. On this one. So on Mission 2, it's reversed. Object A is the heavier one. For Mission 3, I'm assuming object B is the heavier one. Okay, so whatever the heavier object is going to be, it's going to need a lot more force applied to it. And that's the trend that you're going to see. Okay, hopefully you did those correctly. Like I said, I'll leave these on the screen so you can do whatever you need to do with these. After you finish this, you need to answer the reflection question. So let's go to the reflection question. Amplify. I'm trying to keep this video short, but it's probably still going to be loud. Not loud. Long. So go to the next. These are the answers for these questions, but let's go over them together. An object is moving to the left. In which direction would a force need to be exerted to make the object speed up? We talked about that in this thing. It would need to be in the opposite direction. Speed up. So the same direction. So the same direction, if it's already going left, it needs to be going left as well. Okay? Or in the same direction. Okay, if you want to slow something down, it definitely needs to be in the opposite direction. And in this case, it would be right because it's initially going left. Okay, to make something stop, you definitely need to go in the opposite direction. And in this case, it would definitely be right because it was initially going left. Okay, remember this little image? Object A has less mass. Object B has way more mass, has 4 times. The same strength force is exerted on the same direction on the objects with different masses. This guy is definitely going to have a greater change in velocity. So your answer should say something about the same force exerted on them. The less mass one will have a greater change in velocity. Okay? Those are the answers to these questions. Hopefully you got them correctly. But if you didn't, you can fix them here. And then you would click Hand In. All right, Purple Group. Hopefully you were able to get that. Let me show these answers just again, just so you can see it. Pause the video if you need to. And this is the correct answer for these. All right, I hope you have a wonderful day.